Today we are going to present about how thermophysics works in everyday cooking using a pan. So, my name is Nur Fatihah Kasimiti Zaim. For this part, I will explain how thermophysics is applied in daily cooking using a pan. In daily life, thermophysics is very important, especially in cooking using a pan. When a pan is placed on the stove, it is transferred from the stove to the pan and then to the food. This heat transfer mainly happens through conduction, where heat moves through solid materials. That is why pans are made from good heat conductors, so that heat can spread evenly across the surface. As a result, food can be cooked evenly without some parts being overcooked or undercooked. During cooking, the temperature of the pan and food will gradually become similar until they reach thermal equilibrium, where heat is evenly distributed. In addition, a good pan can retain heat even after the stove is turned off, making cooking more efficient and saving energy. Overall, thermophysics helps us understand how heat is transferred and applied in our daily cooking.
Assalamualaikum and good morning everyone. Next, I will present the component of need for Thermapan. So, what physics-related need or concept are you addressing? To answer that question, the physics-related need I'm addressing is to get efficient heat transfer during cooking. In cooking, normal pan often have problems such as uneven distribution of heat, such as cold or hot spot on the dishes, a huge amount of heat loss on surroundings, and inefficient use of energy, such as wasting unnecessary amount of energy and electricity. This creates a need for cooking pan that can distribute heat equally, maintain heat effectively, and reduce energy lost. On the next slide, the second question asks, which specific physics principles are involved? The first principle that are involved is heat transfer. Heat transfer is the movement of thermal energy and can occur in three ways. The first one is conduction, where the heat moves to the pan and the heat from the pan moves into the food. The second is convection, where the heat moves to liquids or food. The last but not least is radiation, where the heat is released from the pan to the surroundings. Out all of these three, conduction is the most essential process. The second principle is energy efficiency. It refers to reduce energy loss during cooking. For example, to this situation, an efficient pan should use less fuel and retain heat longer. Last principle is heat capacity. It is ability of a material to store heat. Not only that, it is also to help maintain a stable cooking temperature even during the heat changes.
Next, I will explain the component of need of our innovative heat control pan. This innovation is very useful in home cooking. The pans help prevent food from burning when frying eggs, pancakes, or meat because the heat is distributed more evenly. It is also beginner-friendly as people can cook more consistently without worrying about the overheating the food. Besides that, this innovation is beneficial for restaurants. Restaurant owners can save energy costs due to more efficient heat usage. It also helps maintain quality of food every time, which is important for customer satisfaction. Lastly, this product supports energy-saving kitchens by reducing unnecessary gas or electricity usage. It promotes eco-friendly food preparation and helps reduce energy waste.
Hi, I am Alia Fakihah. Today I will explain how our product, the Thermapan, works using thermal physics. The Thermapan has a multi-layer design. The base layer uses aluminium for copper to spread heat quickly and evenly. The middle layer contains a phase change material or PCM, which absorb excess heat and release it to prevent overheating. The top layer is a non-stick surface with temperature-sensitive pigments. When heat is applied, heat flows through conduction from the stove to the pan. The heat spreads evenly while the PCM helps keep the temperature stable. Okay, next, how the physics concepts are applied to Thermapan. First, thermal conductivity ensures even heat distribution. Second, specific heat capacity allows heat storage. Third, thermal equilibrium prevents burning. And last, heat transfer occurs through conduction, convection, and radiation. Overall, the Thermapan makes cooking more efficient and controlled.
For the next point, what is the physical processes, mechanisms, or equation that involve? Surprising or not, there is quite a lot of them. First, Fourier's law of heat conduction explains how heat transfer through the pan materials and help distributing the heat more evenly. Second, the heat energy equation, Q equals mc delta T, is used to calculate how much heat the pan or phase change material absorbs. The phase change mechanism, or PCM, absorbs heat during melting without changing temperature, which helps stabilize heat. There is also a small effect of thermal expansions, where materials slightly expand when heated. As a result, the pan provides a lot of useful outcomes and effects such as even cooking, reduce burning, improve energy efficiency, give a visual temperature indicator, and makes cooking safer by preventing overheating.
In conclusion, Thermapan show how physics principle of heat transfer and insulation are used in daily life. It's helped reduce heat loss, maintain temperature, and also improve energy efficiently. We also include the example of brand that apply the Thermapan in their product was Tupperware, Panasonic, and Panasonic.